Hi, my name's Cy Horton and I'm a Global Sales Engineer for our Product Design vertical at FARO. I'd like to introduce you to our new 8-axis DesignScan Arm 2.0. The product itself is designed to complement the existing DesignScan Arm and extend the axis range of the unit itself. The unit is small and portable and can be mounted on a table or on a tripod, and adds an additional axis of rotation for unrivaled flexibility. The unit will support our Quantum series arms, but also our DesignScan Arm series, and has seamless integration with all of the family. The system itself helps you scan smaller parts quickly and effortlessly by being able to rotate them and not rotate the arm. For heavier objects up to 100 kilograms, it makes it easier to access them where we might not be able to reach around the artifact in order to scan. We can simply turn the turntable and continue scanning. With regards to measuring larger objects, it makes it easier, because in an instance like this, we may have had to scan one side, turn it over, scan another side, and then register the two halves back together. Now with the 8-axis system, we don't have to do that. So what are the benefits? We can measure larger parts by using a smaller FARO arm. We have an additional axis of rotation. We have seamless integration with the Quantum arm and the DesignScan Arm family, and no special software integration is required. We can scan into Geomagic products, Cam2 or Polyworks, etc. We scan small parts quickly and effectively, easily access hard to reach details. We can minimize and eliminate device moves. It also gives us a reduced footprint because we're not having to work around the artifact. It also helps ease of use and lowering the learning curve. And it's designed ergonomically to make the user more comfortable, with a weight capacity of up to 100 kilograms. So let's look at some of the product details. It comes in a self-contained box, where you get the 8-axis unit itself, a 250mm plate for mounting your parts on, the mounting plate for mounting on the desk, and hex keys and mounting screws to fix the two together, the shipping case and the interface cable to connect it to the arm. And if you bought the Quantum version, you also get the calibration certificate. The device itself is very small and very portable, with a height of around 230mm and a weight of 4.5 kilograms. With regards to accuracy, using the DesignScan Arm, we've not compromised accuracy at all. We're still up to 75 microns on a 2.5, 110 microns on a 3.5 and 130 microns on a 4 meter arm. But also, because we're minimizing the movement of the arm, we're actually increasing the accuracy because we're not moving the encoders of the arm much further. We also have an accessory for larger objects. So here you can see the work holding kit, which can be put into an array of shapes to suit the product you're physically trying to scan or probe. For ease of use, if you're doing repeat scans or repeat inspections, we also have a quick release kit, so you could have a variety of mounting plates with a quick release kit to quickly remove and add different accessories to them. The plate also comes in a 500mm plate for scanning those larger objects. So how do we use the 8-axis system? Well, as mentioned, we can work with a Quantum E, M or S FARO arm. We can also work with the DesignScan Arm 2.0. All you need to do is install a new driver. So uninstall your old driver first and make sure you install driver 6.2.0.19. Following on from that, make sure your arm is connected to your laptop via USB and install the firmware update of 8.11.4. And then, because you've installed a new driver, you must calibrate the arm and the laser line probe. Setting up the 8-axis unit is very simple. Depending on where you're mounting it, you can use the mounting plate provided, or you can mount it on top of a tripod. You pull the unit out of the box and you tighten it onto the 3.5-inch ring to make it secure. You then, using the 250mm back plate from the box, place it on top of the unit, line up the holes and attach it using the 4 screws provided. We then plug in the auxiliary cable and the USB to the rear of the arm, and then plug the cable into the rear of the 8-axis unit. Note it's a twist connection, so twist it gently until it just pops into place. And at that point, as long as your arm is on, the green LED should turn on. You then open up the FARO Arm Manager, and once you've got both pieces of equipment connected, you scroll to the bottom and the driver should now have a new section called 8-axis. You click on the Enable button to activate the 8-axis, and then now we need to tell where each axis of the arm is in relationship to the 8-axis. So we push the Compensate button and then simply read the instructions. Note, we also have a half rotation option here, and this is for areas where we might already have a part located on the plate and we physically can't do 2 full rotations. So to compensate it, at 90-degree intervals on the plate, we have 4 conical holes. You place your sphere in one of those holes, and then you choose which direction you're going to go in, and you perform 2 rotations. Once you've done the first 2 rotations, the system will tell you you're going in the wrong direction. So you simply reverse that direction and do 2 rotations in the opposite direction. When you finish, the results will come up and tell you whether you've passed in vertical, radial and tangential. And you simply accept the results by pressing Save and Exit from the FARO Arm Manager. Now you choose which software you want to use, and when you open it up, in the bottom right hand corner it should tell you that the FARO 8-axis is on. So let's look a little bit about scanning and the techniques involved. So here you can clearly see the 8-axis unit mounted on a tripod, and I've chosen artifact to scan, and simply by rotating the table I can then scan around the artifact using the DesignScan Arm 2.0. So if I take the arm and start scanning, then here there's a combination of methods I can do. I can either scan a stripe along the base of the unit, or as I'm scanning I can start to rotate the unit at the same time. I find a combination of both quite handy because it helps minimize the movement of the physical arm. Therefore we're restricting the encoders and in turn increasing the accuracy of our arm. So it's just a case of moving around the artifact and turning the table, doing several scan passes until we've captured most of the data of this artifact. And it's a very easy, very fluid movement. It makes it a lot easier to scan around an object rather than having to reach over it, risk knocking that object. Using the 8-axis we can simply turn it to the angle we want, thus enabling the line of sight for the blue laser to capture every single detail on this particular drill that I'm scanning here. And from a user perspective it's a lot easier. It just makes it less tedious to move around and a lot more of an enjoyable experience when scanning artifacts of this nature. You could simply leave it still and scan across, but as mentioned, moving it a little bit at a time helps you just get into all those nooks and crannies on this particular drill. So when you're happy with the data, I'm just going to stop that and move back to the PC. So now we're back sitting at the PC, you can see the amount of data I've captured very quickly. If I just close the plugin down, the first thing I would probably do here is go to an alignment and I'd do a global registration. And all this is going to do is fine tune all those scan passes that I've done. When that's complete, I click OK and I've now got my scan group. What I would probably do next is go in and combine those points to thus remove any overlap between those scan passes. That's now complete and we've reduced the number of points by well over a half by doing that. Probably the next process I would go through is to run a uniform filter across the data. So here we're looking for a certain spacing and we're trying to maintain points over curvatures to give us a smooth mesh. So if I just click apply to that and let it do its thing, again we've reduced the number of points in here. So I'm going to click OK and probably the next thing I do is jump straight in and wrap it to convert that point cloud into a mesh. So that's now complete. I actually took the liberty of scanning a little bit more of the drill just to fill in some of the blanks that I'd missed. And as you can see, I've captured an awful lot of this particular artifact. So the benefit of the 8-axis DesignScan Arm 2.0 is that you don't have to rotate and scan from multiple directions and then perform a registration afterwards. The system allows you to rotate and be more flexible and makes it a lot easier to scan complicated objects. Thank you for watching. I hope you've enjoyed watching the workflow. And for me, the 8-axis DesignScan Arm 2.0 is a great asset to the FARO family.